Welcome to the Southern District Annual Meeting Technical Session number 6. This is Option A, New Tools and Techniques in Highway Safety. First up is Improving Pedestrian Crossing Safety Along Major Arterials in North Carolina, presented by Brian Mayhew and Lauren Blackburn. Brian is a state safety engineer for the NCDOT. He manages several state and federal transportation safety programs for NCDOT. He works to establish comprehensive and multimodal approaches to ensure safety is sustainable in North Carolina. His intent is to have safety programs that deliver practical solutions and work to minimize harm to users. Current focus is to further integrate safety into transportation systems and the programs that influence. Mr. Mayhew is has a BSc from NC State and is a registered professional engineer in North Carolina, has worked for a North Carolina Department of Transportation for 25 years. Ms. Blackburn is a senior project manager with VHB. She has over 17 years of experience in multimodal and long-range planning. She is based in VHB's Raleigh office, and his key areas of interest is bicycle and pedestrian transportation, comprehensive planning, roadway safety, and community health. Prior to VHB, she worked for NCDOT as Director of Division of Bicycle and Pedestrian Safety. She has a bachelor's in landscape architecture from Arkansas Fayetteville and master's in urban planning from University of Illinois Urbana-Champaign, and is a member of the American Institute of Certified Transportation Planners. Take it away.
All right, thanks, Valerie. So as mentioned, we're going to share a little bit of information today about pedestrian safety and our programs in North Carolina with NCDOT. The main focus will be on arterials. I'll share a little bit of information about our programs, and then Lauren is going to go through a case study on a corridor that we completed somewhat recently. So, next. So in North Carolina, it's important as background that we adopted the North Carolina Strategic Highway Safety Plan in 2019. This is a pretty broad-based plan that was put together by stakeholders from all across the transportation system and different user groups across North Carolina. But one of the more important things that this plan established was a goal for North Carolina, and that's to reduce all fatalities and serious injuries by half by 2035. Moving towards zero by 2050. So that's a pretty aggressive goal, but this should inform many of our policies and programs and decisions in North Carolina as we go through. Next. So the Highway Safety Improvement Program, we do align it with the Strategic Highway Safety Plan. This is an infrastructure safety program, and so it's focused more on improving the roadway to have the safety results that we would like to accomplish. It does include a focus area on pedestrian safety. It's a broad-based program for intersections, lane departure, but does focus specifically on improving pedestrian safety across the state. Next. So many people have heard about the pedestrian safety trends recently across the country, and it's definitely pronounced in the South as well and in North Carolina. But those pedestrian safety trends in the last decade alone, fatalities have increased over 50%. That's a national statistic, but it's pretty much in line in North Carolina as well. Almost all of that increase has occurred in urban areas, and almost all of that increase has occurred specifically on urban arterials, and that's true in North Carolina as well. Rural pedestrian fatalities have stayed relatively constant over time, but our urban areas and arterials are seeing most of the increase. Characteristics for this pedestrian fatalities are darkness and crossing are very, very common. Almost all of that increase, about 90% of that increase in pedestrian fatalities has to do with people trying to cross the road between intersections and in darkness. Those conditions are pronounced in pedestrian fatalities, but they're more significant on urban arterials. High speed, that's well documented as a risk factor for pedestrian fatalities. Again, our urban arterials, about 68% of that increase in fatalities have occurred on urban arterials where speed limits were greater than 40 miles per hour. So in North Carolina, the risk of death and serious injury on urban arterials is 5 times greater than other urban roads. And so that's why this is a common theme for us in North Carolina. Our pedestrian safety improvement program, which is part of our HSIP, we look at pedestrian safety in 3 main ways. And the first one we're not going to touch on much today is responsive. And that's your typical black spot or hotspot type of program where it's reactive based, right? Crashes have occurred, crashes have happened. They've accumulated enough to be significant and get attention, or perhaps we've received requests for assistance or complaints from citizens or cities, local government, and so we're responding to those requests, and that's typically pretty effective. You can get a pretty good pedestrian safety projects from that type of program, but it misses a lot of opportunities to improve pedestrian safety because pedestrian crashes do not always follow standard ways of accumulating in one spot that you can treat, right? There's a lot of risk factors that we just went over on those urban corridors in particular. So we have to look at other data sets in addition to just crash data in order to fully understand and really to be able to fully develop a program to focus on pedestrian safety. So with the city and area and the corridor, those are much more systemic based, where we're using a lot of different data sets and understanding how those data sets relate to pedestrian safety and risk. And we'll get into that a little bit more today on the corridors in particular. So in North Carolina, our corridor risk scoring method, as you can see, and we just mentioned with the systemic approach, is it does include crash data. Severity and frequency and density of crashes is considered, but we also look a lot for roadway characteristics as well that we know contribute to the risk of a pedestrian crash occurring and the risk of death and serious injury, such as speed and ADT, crossing distance, and distance between signals. We know that those relationships exist, and we know that they can be very relevant in how we make decisions for pedestrian safety. Probably some of the biggest area for growth in understanding pedestrian safety in the recent years has been in the demographic type of information, using different census data, transit density, land use and population density, different levels of vehicle ownership. All those are very important. In the case study that we're going to share in just a minute, you'll see a lot of those things come up again and again in that process. Again, using risk-based screening has been very helpful in prioritizing different sections, looking at income level and understanding pedestrian volume. This is a big one because we know that pedestrian exposure is very significant in how it relates to the opportunity for pedestrian crashes to occur. But it's very difficult to find very rich data sets for pedestrian volume. So it's, again, very important to look at land use and transit and different census data in order to kind of understand where that exposure may be higher, and then allowing that to help inform our programs as we select corridors for further improvements. But eventually, after you select corridors, we do need to go visit them. We do need to make sure that our programs involve reviewing and really trying to find some low-cost safety improvements that can be implemented quickly. That's a big focus of our program, is to be able to move quickly to address safety. So low-cost projects that have a big impact on safety are always our first consideration. With that, Lauren's going to go over a case study on NC54. This was a great project that involved VHB, NCDOT, and a couple of local governments and various agencies. Lauren?
Thanks, Brian. NC54 began as a study for a number of stakeholders in late 2018 after several agencies, including the towns affected, had identified this corridor for some pedestrian safety concerns. So NCDOT convened that group of stakeholders, including the towns, transit agencies, and others, to look at this corridor and talk about what some recommendations might be for improving pedestrian safety, considering elements of risk. So VHB was glad to be a part of that team, and we finished the study in late 2020. So NC54 is a regional corridor. It's an east-west corridor that connects the Greensboro Triad region all the way to the Raleigh-Durham Chapel Hill Triangle region. It functions as a major regional commuter route for a lot of folks who live in the Piedmont region of North Carolina. We focused on a 4.5-mile section of 54 that passes through the towns of Carborough and Chapel Hill, and also borders major destinations such as UNC Chapel Hill and the Healthcare Center. So NC54, built many decades ago, was first established to facilitate that regional transportation, but over time development, housing development in particular, the introduction of transit networks and other growth have changed how people use this corridor and how they interact with it. So that was an important prompt for us. The study team identified a lot of different locations of interest, but many cases we saw activity like you see here in this photo. The towns in our stakeholder team noticed people crossing NC54, which is a high-speed multi-lane corridor such as what Brian was talking about earlier, oftentimes at uncontrolled locations, mid-block, maybe thousands of feet away from the nearest intersection or traffic signal, ultimately trying to get to their place of work or school or accessing transit. So it highlighted the importance of looking at this corridor for all roadway users. A typical process that we've been following for corridor studies, of course, always begins with data collection. We go into the field, we observe conditions, identify where we need to collect additional information, and begin talking to different stakeholders. Part of this process has also involved interacting with the people who live and work along the corridor. So, of course, this is pre-COVID, but we were able to have a couple public workshops in the two towns where we asked people about what their experiences have been like and to help us understand what may be underlying some of those safety problems that we had identified. And then ultimately, we use that data to help develop and test different concepts or recommendations for improving pedestrian safety, as well as for bicyclists, but also thinking about how this wove into a larger concern or conversation about how this corridor functions as a system for mobility for pedestrians, bicyclists, drivers, and transit users. So thinking beyond specific locations or specific crash locations, how does the entire system work together to improve mobility and safety for all roadway users? So as part of the initial field review, we were able to work with Chapel Hill Transit to put the stakeholders on a bus. We drove the corridor, stopped at multiple locations, observed people, traffic, physical conditions, potential safety issues, and convened the stakeholders back together, listened to each other's observations, took notes. And so things that we would have noticed in the field looked a lot like what you see in this slide, where some folks were identifying how people were crossing the road, what direction they were traveling. In some cases, we were able to talk to people as they were crossing the road or after they had crossed the road to talk to them about where they were going and learning a little bit more from people in the field. And other notes, especially from those who have had more experience with this, identifying even some potential recommendations while we're in the field. At one location, some of the NCDOT staff identified some immediate opportunities for improving crossings at a major intersection on the eastern end of the corridor. So the team also wanted to hear from people who live along the corridor. We posted an online survey. We posted a QR code in the bus shelters along the corridor, and that helped generate a lot of public feedback. We had over 700 responses from people who live and work along the corridor, a lot of folks who use transit, of course, but others who were students or maybe just got communication from the towns. And we asked them questions about what their experiences have been like, what their observations have been. And so a lot of that confirmed some of the safety concerns that Brian mentioned earlier, which is concerns about how pedestrians were crossing and walking along the roadway, especially in dark conditions, and especially in the sections of the roadway where speed and traffic speed are highest. So this helped validate some of those data points that we had collected. So we did look at pedestrian crash locations in the history, and for arterials like this, pedestrian crashes may be far and few between. When they do occur, oftentimes they can be more severe or fatal. So we took a good look at that, but of course, the patterns may not be very revealing. So we considered that where the crashes have occurred, but also looked for ways that we could fill in the gaps to understand risk. So we collected data about speed, traffic volume, pedestrian activity. We wanted to have a better understanding about the traffic speeds relative to the posted speed. So the posted speed was 45, and in some cases, the 85th percentile speed was in excess of 55 miles per hour. So that middle section of the corridor, especially where there are uncontrolled crossings, a lot of apartment complexes, those speeds were especially concerning to us. So we were thinking about how that translates into risk. And if you can see here that the ADTs on the western end, nearer to the Carborough end of the corridor, are about 20,000 vehicles per day. That doubles on the eastern end. Part of that's how it interacts with other major corridors that go north-south throughout the study area. But approaching 40,000 vehicles per day, that certainly limited some of the options that we could consider, but it just made this risk and exposure all the higher. So when we have transit on the corridor, it becomes a really important data point for us to collect. We worked with Chapel Hill Transit to collect boarding and alighting data. We mapped that along the corridor where there were bus stops. So the bus stops stop in the eastern third of the corridor, but where we did have bus stops, we not only looked at the number of people getting on and off, but the balance of the number of people boarding and alighting at a particular bus stop. So how many people were getting on and off at the same bus stop, or where did we see some particular imbalances? So for example, if you look at the intersection of Laurel Ridge Road and NC 54, you can see that that pair of bus stops across the road have a major imbalance. A lot of folks getting on one bus stop and then getting off on the opposing bus stop. So that led us to understand more about what may be happening along the corridor. The pedestrian volume data, the crossing data in particular, confirmed a lot of what we were beginning to think about the corridor, where we saw those bus stop pairs, and the imbalances in the alighting and boarding. We saw the heaviest pedestrian crossing data. If you think back to that crash map that I showed earlier, there were very few pedestrian crashes in that middle section, but the risk is highest in this section. So this may be a lot to do with the abilities of the people who happen to live along the corridor, the younger population, the student population that lives along the corridor, but that doesn't reduce the risk for pedestrians in general. So we paid close attention to those uncontrolled crossings in the middle section, but we also looked at signalized intersections where we saw fairly heavy pedestrian activity. So all composed together a risk factor map for the corridor. This helped us to prioritize the locations that we wanted to delve into the most. And so that helped us, again, focus on that middle section where speed, volume, pedestrian activity, transit stops, and development were pointing us to the highest risk. So this middle section got a lot of our attention, but certainly we identified recommendations for almost all of the intersections along the corridor, as well as some considerations for how the network functions overall. And so considering how transit was an important risk factor for this corridor, we did think about how we could maybe consider some transit alternatives. What would happen if we were to propose route changes, scheduling changes? Would that impact pedestrian activity and safety in a substantial way? Looked at several alternatives, and this was just to understand if there was an easy win, an easy way to be able to address this. But considering that these are people who rely on transit to get to where they're trying to go, there was a balance between their own mobility and how that the changes to the transit system may impact that. So we looked at several alternatives and really couldn't find a good alternative that was likely to reduce that demand for crossing. So we did coordinate this with Chapel Hill and Transit, and it led us to know that we needed to look harder at ways that we could improve the physical crossings along the corridor. We coupled this information with what we were hearing from the towns as well as NCDOT about the future for connectivity across and along the corridor. A lot going on here. The towns had plans for bicycle and pedestrian networks, both along 54 as well as parallel to NC 54. NCDOT was preparing to study the eastern end of this corridor for a major widening improvement. And then also we looked at physical proof that there were people walking behind the corridor. So worn paths in some of the natural areas connecting those apartment complexes, which are typically isolated and not connected into a larger transportation grid. So we looked at all of that to help us better understand how people were moving along the corridor. And that helped us develop what we were calling a connectivity plan. So the intent is not necessarily to build all of this network as part of the safety improvements, but again, to help us understand where are people most likely to cross NC 54 today, as well as in the future, lining that up with risk, lining that up with where the towns were going in terms of some of their short-term projects, where they were building new greenways, for example, along NC 54, where were those likely to come up to NC 54 in the near term, to help us make sure that we weren't overlooking any important crossing opportunities in the future. So altogether, we looked at improving pedestrian safety at multiple types of conditions, signalized intersections, several uncontrolled crossings, like I mentioned, where there were no formal crossing accommodations, no traffic signals. That was an important part of this study as well. And then continuing to communicate with the towns about how we could integrate their connectivity plans into longer term improvements as well. So the study team, including the towns, have continued to use this study for their own work to prioritize some of the pedestrian improvements that they're planning to build nearby. And then NCDOT continues to look at some of the recommendations that, as Brian mentioned, could be implemented in the near term, especially where those low cost improvements could make a big impact on improving pedestrian safety. So with that, I think that'll cover the study area and the study process. And Brian, I don't know if you have other things to add about where things go from here.
You're on mute, Brian. Uh-oh.
Uh-oh.
Oh, there you are.
All right, there we are. Thank you. Yeah, on this corridor in particular, it was it gave us a good opportunity to really think through a lot of the risk factors that we had been working with for some time, but and being able to see how those really did work in terms of identifying risk and helping us prioritize efforts was beneficial. So those processes will continue to be refined, and the program will continue to become better established in terms of safety planning. On this corridor in particular, I will say one of the key takeaways really was the involvement of land use and transit and how that affected the pedestrian movement through the corridor. It was until you understood that, there was going to be very little chance to really make significant safety, improvements on this type of corridor. So that was definitely a key takeaway. As Lauren mentioned, there have been many improvements identified on the corridor. Those are being worked through in a continuous fashion, and hopefully some of those will be implemented soon.
Okay, I've got a question for you all. Have you investigated into using RRFBs and or hawk signals for the non-signalized crossings?
Yeah, I'll answer that in general, and then Lauren may have some specific comments on this corridor. But yes, so we do use those in North Carolina fairly extensively. We'll use both the hybrid beacon as well as an RFB. I will say that a rapid flashing beacon on this type of corridor is generally something that we would not look to do, just because of the travel speeds are very high on this corridor. And you also have multi lanes, and so the multi-threat situation could be very significant on this type of corridor. But in general, across the state, we do look for opportunities to use those where we think we can increase yielding to pedestrians at a crosswalk that's already been enhanced. As far as the hybrid beacons, those are something that are being considered on this corridor. Again, it operates as an expressway in part of the corridor with interchanges. So with some signals on either end. So some of our context on this corridor is going to be between thinking through a hybrid beacon approach versus pedestrian traffic signals that may work better on this type of corridor. But it's always context. You always have to use the context of that location to help make those decisions. Lauren, was there something you wanted to add on that?
Not really, I think, but we did test alternatives for both hybrid beacon and traffic signals at some of those uncontrolled crossings. And because of what you just mentioned, the proximity to other signalized intersections, the off-ramps, wanted to think about how drivers would likely use those signals. Would they stop? Would they see the pedestrian? Would they expect pedestrians with a hybrid beacon? Would it be more effective to use a traffic signal?
All right. If any of the attendees have any questions, you can either type in the chat or there is a question thing. And I guess it's time to move on to the next presentation. Thank you, Kevin and Laura.
Thank you.
Okay, let's move on. So for our next presentation, we have straightening out the horizontal curve dilemma, presented by Jay McComb, Joe Caruso, and Mike Vaughn. Jay is Vice President of Quality Counts with more than 30 years of management experience. He has responsibility for all horizontal curve assessment projects, which have included statewide efforts in Ohio, New York, Kentucky, and South Carolina, as well as smaller projects throughout the U.S. Under Jay's leadership, Quality Counts has become the largest horizontal curve data collector in the U.S. with over 85,000 centerline miles collected and processed, and 500,000 signs inventoried. Jay is a member of the QC executive team and sits on the board of directors for Quality Counts Holdings. Joe Caruso is the product development manager with Riker Inc. His most recent role is as technical sales engineer for Riker's Curve Advisory Reporting Services, otherwise known as CARS, a SaaS product that leverages Riker's unique transportation sensors to fully automated the setting of advisory speeds for DOTs. In this role, Joe is responsible for business development, customer satisfaction and support, and technical enhancements, working closely with both Riker's engineering team and customers. Mike Vaughn is the transportation engineer specialist with Kentucky Transportation Cabinet. Mike has worked for the Kentucky Transportation Cabinet since January 2003 and the HSIP section since 2014. He's one of 3 engineers who administers Kentucky's HSIP. Mike earned a BS in civil engineering from the University of Kentucky. And this is kind of interesting. And he must be important because he put it on his resume for this. His favorite hobby is playing Texas Hold'em, and on June 20th, 2016, he checked off a bucket list item when he played in event number 23 at the World Series of Poker in Las Vegas. Take it away.
Thank you. So to introduce Quality Counts a little bit, we are a traffic data collection company and data management company. Our expertise is in the first part of any traffic study is collecting the data and then managing it in a way that you, the engineers, can make sense of it and provide good recommendations and make the transportation network even better than it is. And we have 10 offices across the country. 4 of them happen to be in the Southern District. We have an office in North Carolina, Tennessee, Louisiana, and Virginia. As as Valerie said, we are a very significant part of doing the horizontal assessment, curve assessments, which we call HCA. And the importance of doing that is because the #1 crash category in the US for the last 10 years has been single car roadway departures at horizontal curves. And that represents 28% of all highway fatalities. And that's a real significant. And the fact that the Vision Zero, MUTCD, and the 2012 study by Penn State, along with other studies, has shown that proper signage, accurate striping, and consistent advisory speeds for horizontal curves is the #1 deterrent in roadway departures. And that picture there is actually probably the most famous roadway departure of the last year in Tiger Woods' Genesis. So in order to do a comprehensive survey, you have to, and to understand what the signage needs to be, you have to do a survey of all the curvature of the road, of the whole network. It needs to be completed for proper signage, proper advisory speeds. And the old way of doing it, the traditional ball banking method, was one, expensive, very time consuming, dangerous, and it introduced human error to the equation. You have to have 2 people in the car, one to drive slow and smooth, the other one to read the inclinometer. You have to take it multiple times at different speeds. So that requires turning around sometimes in dangerous conditions where line of sight is not very good. So Riker, the leading manufacturer of inclinometers, came up with a solution. They identified the need after the 2009 MUTCD was updated, and went on to develop the CARS Advisory Reporting Service, CARS. This is a patented technology that automates curve and sign data collection processes. And so far in the Southern District, Kentucky, Mississippi, Georgia, Virginia, Alabama, and South Carolina have all adopted the use of CARS, some doing it in-house, some doing it through an engineering firm, and some doing it with a data collector like us. So I'm going to take a minute and send it over to Joe Caruso to talk about CARS a little bit. Joe?
Thanks, Jay. Yeah, Riker is a 104-year-old company that patented the ball bank back in 1939. So we've been involved in doing advisory speeds and providing the equipment for advisory speeds for over 60 years. And introduced the electronic ball bank in the 90s, back in the 1990s. But as Jay said, we know that that's a very time-consuming process, and it's very dangerous because the process involves the driver driving at incremental speeds of 5 miles an hour, faster, 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 until they get an alarm, that side friction alarm, which means by definition that the driver is driving at the limit of the side friction for safety. So it's a dangerous proposition, and they have to turn around in a blind corner, and it's very time consuming. We also know that they had to choose specific curves. So you had to choose your location, your survey site, which means you left a lot of the road unsurveyed. So in 2012, we set upon the mission to fully automate that. So what CARS does, it's a SaaS service, SaaS service, a SaaS service that's completely virtualizes, completely automates the job of ball banking. And the most important feature in my mind is, the two most important features in my mind is, one, it allows you to survey the entire network completely hands-free. So you don't have to decide if you have a curve or not. It surveys the entire corridor hands-free, and also allows you to do it without turning around at any speed. So you can drive with traffic, you can drive slow, and you can keep your eyes on the road. So it really improves the safety of the operator and the technicians out there in the field. And it really lowers the cost because now you cover your entire network. So we invested that starting in 2012, patented in 2014. Actually, the patent came in 2015, but we started rolling it out in 2014, and it's been growing in its adoption ever since. and we'll continue to invest in it. Our plan for 21 and 22 is to invest a significant portion of our R&D capital in improving the platform.
So in addition to the CARS solution, in 2016, we had our first statewide contract in Ohio where we surveyed about 18,000 centerline miles in Ohio. And we started developing some of our own internal systems, such as routing. In Ohio, we use the spoke and wheel type system for collecting data, where we use Columbus in the center of the state, had drivers stationed out of there, and then would send them to different parts of the states to collect data. Obviously, as we got further out, we'd have overnight trips and that kind of thing. So routing was very important to be efficient. In addition to that, we also had to have some GIS tools developed in-house to track our progress. You can see from this slide, this is actually New York, in which the blue represents routes that we had driven at the time of this screenshot. The red was the routes that had been planned at that point. So we started actually in Rochester in New York as our spoke. And from our experience in Ohio, we realized we needed to do some other systems, and so we created 2 hubs in New York, one in Rochester and the other in Albany, and did the whole state through those two hubs. In addition, other solutions of our platform, we have the data management, just making sure we're managing it correctly, make sure the data is correct, and that we have good quality on all of it, good GPS fits, in addition to safe driving speeds, proper driving speeds, such. And so we created some scripts that we could run through the data so that we could find anomalies and provide a QC system for it. So to get into some case studies, South Carolina, we actually started our first contract in 2018. It was for about 4,300 miles. That contract, we learned a couple of things there too, just like we learned in Ohio. One is we tried to do it with, since it was a much smaller portion, 4,300 miles, we thought we could manage it out of our Charlotte office for the most part, with current employees, and that we did it. It worked, but it wasn't as efficient as we wanted it to be. So when the second contract came up for it, we did it a little differently and created 3 hubs, one in Charleston, South Carolina, one in Columbia, and one in Greenville. So we kind of peppered the state with them and had drivers that we hired locally from each of those, trained them, and got the data collected pretty quickly and then processed through it. So typically in these projects, you have route planning, which is kind of the first part. While you're route planning, you're hiring and training data collection drivers. We have a curve processing machine of a couple dozen folks that can process through the Riker portal from their homes or from one of our field offices. And then data organization is, again, I mentioned, is very important in our QA/QC system. Inevitably, you have to go out and redrive some routes, some curves, because the data wasn't good. You might not have had a good GPS fit. The driver might have swerved to not hit a dog or something like that in the middle of the curve, so you have to recollect the data. Our standard procedure is to do two passes in each direction for every centerline mile. There's not much of an incremental increase if you're already out there and doing it twice. So we'll have, between 50 and 70 miles that we'll drive 2 times in each direction, so 4 times total on any given route to collect data. South Carolina, we did not do a sign inventory for South Carolina like we have done for multiple other contracts. They had a good sign inventory in place, but we were able to work with them very, very closely and provide good data. And it was a very good contract for us, both of them over 2 different. NDOT took a different approach. They contracted for the software as a service through Riker, got the kits and had internal folks do the driving through their network. When they were close to being done, they contacted Riker and simply asked, how do we know this data is good? And Riker, Joe, suggested we do they contact us and we can do our quality control on it. So we did do a contract with them just to do the quality control, very inexpensive for them to do that. We were able to find some areas that they needed to redrive or found some problem areas, but for the most part, they had done a pretty good job. But as Joe likes to say, two curves are they're like snowflakes. No two are the same. So sometimes having that expertise of handling so many curves is helpful, and having so many different people in our organization that have experience processing curves is very helpful as well. Our next contract we're going to talk about was KYTC, and I'm going to turn it over to Mike Vaughn. We actually, in this contract, we did do about 27,000 centerline miles of surveying. We also inventoried not only the signs associated with curves, but we inventoried all state signs projects. Since we were driving it anyways, we were filming as we go. We then just went and reduced that video down and processed close to 500,000 signs in that process. Quite a project for us. So Mike, if you could take a few minutes.
Yeah, thanks, Jay. So one thing I want to point out, and I want to talk about the sort of what Kentucky is doing with all of the curve data that we've received through this project, because it really is more than just recommended advisory speeds. You can get begin and end mile points of each curve, curve radius, curve length, deflection angle, the approximate super elevation at the critical point. So there's a lot of supplemental or additional data that you get from the CAR system. And so basically what it allows you to do is create a very robust curve database. And any of you out there that's familiar with different ways of data analysis, having a robust database is a really good thing. You can do a lot beyond just determining MUTCD compliant curve signing. So currently in Kentucky, our HSIP is in the process of integrating the past 5 years of crash data with our new CARS curve database. From there, we're going to perform a variety of analyses. One analysis that we're going to be applying is network screening methodologies from the Highway Safety Manual for all the curves. Essentially, our goal there is to look at all the curves and determine the excess expected crash frequency. Once we get that value, we can then begin prioritizing safety studies for the curves that have the greatest number of excess expected crashes. Another analysis type that we already began performing is systemic safety analyses district by district. We have 12 districts across Kentucky. The goal of a systemic analysis is to determine which combination of curve features are most correlated with severe crashes. In other words, we're trying to determine curve risk factors. And once we know each district's unique set of curve risk factors, we can then focus on implementing enhanced signing at the subset of curves that have those particular risk factors. Just a make-believe example, maybe we find in a particular district that the greatest risk for severe crashes is curves that are preceded by a tangent of a half a mile or longer. The curve radius is between 600 and 1,200 feet, and it's a curve along a rural 2-lane roadway with a posted speed limit of 55. So if that combination of factors is what we were to find, we can then single out the subset of curves that have all of those factors and implement some sort of enhanced sign package, beyond the minimum requirements listed in the MUTCD as a way to try to mitigate the additional risk that those particular curves have. Another idea that we have with this robust curve database, and I think it might be one of the more interesting things we're hoping to do with this, it involves pairing up the curve data with continuous pavement friction data that we're currently in the process of collecting. We have a contract with a different vendor to collect continuous friction data along the vast majority of our roadway network. And the idea that I sort of have is to use the simplified curve equation from the Green Book to calculate the theoretical friction demand for each curve. If you're not familiar with the simplified curve equation, there's 4 basic variables: curve radius, speed, super elevation, and then friction. We're getting radius, advisory speed, and super elevation from the CARS data, and any curves that don't have an advisory speed, we would use the posted speed limit. But with those 3 data points, we can then calculate the theoretical friction demand for each curve. And we can then compare our theoretical friction demand with the actual friction that was measured. So the actual friction supply. And so my idea is to take the friction supply, what we actually have out there, and divide it by the theoretical friction demand. Now, obviously, this ratio needs to be greater than 1. If it's less than 1, then that would mean our friction supply does not quite meet the theoretical demand, and that would be a bad thing. That would mean anybody that drives through that curve is likely going to crash. We're not going to find that, I don't think. The pavement would have to be extremely polished to get into sort of that dynamic. The friction factors suggested in both the Green Book and MUTCD and what's used in the CAR system are conservative friction factors to set advisory speed. But what I do think we may find is that there are some curves whose pavement has become polished to a point that when you do the friction supply divided by friction demand, you're getting precariously close to 1. So you still have enough friction, but you're getting down near where it's starting to be worrisome. And so, similar to how we would utilize factors of safety when you design a bridge, my hope is that taking the actual friction supply divided by the friction demand can act as a friction factor of safety, and it's going to let us as safety professionals determine which curves need to be prioritized for a friction treatment. In some of those, it may need to be high friction surface, but there could be other friction treatments that are a lot lower cost than high friction that we can use to basically maintain a certain level of safety for the friction. There's some other uses that we do have planned for the curve database beyond the few I've shared, but we want to get through the remaining slides and have time for some questions. So I'll turn it back over to Jay.
Thanks, Mike. It's good to know that the data we're collecting isn't just for one purpose. And I've really enjoyed working with Mike on this project and being able to learn more what the data can be used for. So basically, any part of a horizontal curve assessment project has pain points. In hiring and training staff, it's one of the biggest ones. There's drivers, data collectors that you'll train, and they're driving vehicles. Our methodology is to use rental cars because you're putting a lot of miles on vehicles, not just the centerline miles, but the deadhead miles going and coming to start and stop points. So we really use rental cars to put the miles on, and if you rent rental cars for extended period of time, you can get some really good deals on them. But you have employees that are driving rental cars, so you want to make sure they have a good driving history, make sure they're responsible, all those things. It is a process to hire the right people. And then sign processors. Like I said, we have couple dozen folks that are trained and capable of doing that at this point. But it takes every sign, or not just sign processor, but curve processor. It takes about a week to 2 weeks to train a good curve processor and a sign processor, knowing all the codes needed and being able to use the video to be able to use the portal and that kind of stuff. So we do extensive training for our folks. Route planning, we're constantly improving that. We're getting ready to use a GIS system for our next project. We do have separate GPS. The past projects, we've had separate GPS Garmin's that we use for routes that we put the drivers to. Now we're going to use a GIS system, so it can be on any smartphone, which hopefully makes it easier, less stuff in the car that the driver has to keep up with. Project management is very important. Being able to keep all the wheels running at the same time and being dedicated to keeping the train on its tracks. Data management, talked about that in QC, QA, or QA, QC. Quality control is a huge thing that we keep up with, and it is one of the biggest things our process involves. So if you're thinking of doing those, doing an in-house project, this is where your pain points. This is how you get a plan for it. In conclusion, I would just suggest that if we can help you in any part of that, we can help you, just consult you and tell you how to go about planning it, how to go about hiring, and all the different steps you have. Or you can do part of it yourself. If you have people that you feel like can do the driving well, but not the processing, we can do the processing for you. If you think you can do the processing but not the driving, we can do that. Any aspect of it, we can, like we did for Mississippi, we can do the QC, QA. We can do the route planning if that's part of what you want us to do. But we can help you in any aspect. Even if you want to do it all in-house, we can tell you how to go about doing it. In my opinion, I think it takes a dedicated team to do it. If you have people that have other jobs, like we tried in first contract in South Carolina, you tend to have some people not taking responsibility for their portion of it because they have other responsibilities. So I suggest a dedicated team, but it can work other ways as well. So at this point, are there any questions for any of us?
I got one. For the curve advisory reporting service, did you verify the results with other methods? What type of accuracy/error can you expect?
Sure, I'm going to let you take that.
Sure, yeah. So we published that as part of the manual. And again, it's pretty well automated, but we have two. There's, as Mike mentioned, we determine the proper parameters for solving the speed equation, which is position. So you have this positional data that comes from the GPS, that's velocity and lat long and that. So our GPS is accurate to 2 meters or 8 feet, so plus or minus 8 feet. And the inclinometer is accurate to nominally to 0.25 degrees, which exceeds the MUTCD requirement of ½ a degree. So we guarantee the ½ degree, but we typically provide 0.25 degrees. If you take those two parameters, the 8 feet on the GPS and the 0.25 on the inclinometer, there's also a vertical component plus or minus 1 foot up and down, and there's a speed of plus or minus 1/10 of a mile an hour. So when you add all that up, what you wind up with is a typical accuracy band, or error band, I should call it. We call it an error band of about 1.5 miles per hour for an average curve. So an average curve to us is a 40-mile-an-hour advisory curve with an 800-foot radius. The error band changes a little bit depending on speed and radius, but if you took an average curve 800-foot curve going 40 miles an hour with a nominal super elevation, and you rolled in all those accuracies, you would get a precision of about 1.5 miles an hour, which is, you know, probably a factor of 5 better than what you would get with eyeballing a ball bank or doing it the manual way. So the summary would be 1.5 miles per hour, plus or minus 1.5 miles per hour on the answer that you get from the CARS report.
Hey, Joe and Jay, I'll jump in too and say that before we invested in the CARS system, we had the University of Kentucky compare CARS to our traditional digital ball bank. So they went out and sampled a bunch of roadways in central Kentucky, close to the university, and they went out as a team and ball banked kind of the old way and recorded the advisory speeds they determined through that method, which is the method we had been using in Kentucky. And then the CARS, Joe at Riker was nice enough to loan us a system for a couple of weeks while we went out and tested it. And if I don't remember the exact stats, I think it was 95% of the time the old way and CARS agreed. And the few instances where they didn't, traditionally or typically, it was the CARS system was a 5 mile per hour increment lower. And, you know, and so that it's like Joe says that, you know, when you're using different machines, you're going to have a little bit of an error band, but we found it to be very, very consistent with the digital ball bank indicators that we had been using in the past. So we were pretty comfortable with those results.
I remember that study. That study lasted after we got the equipment back. I think that study went on for about 6 or 8 months, if I recall, and pretty comprehensive report which is available on the internet and also on our website if anybody's interested. I think they studied about 3 methods, if I'm not mistaken, and compared them to ground truth.
Yeah, they actually went out and surveyed some curves.
A ball bank method and a car, along with CARS. And yeah, we were real pleased, obviously, with the results. That's why we promote that report. I think it's out there also with a similar study done from the University of Oregon DOT and the University of Kentucky were the 2 probably largest studies that were done. They're both published and they're pretty comprehensive. As you said, Mike, it was very rewarding to see the results from an independent academic like University of Kentucky, UK.
I got one more question, then we'll move to the next speaker. From municipality perspective, does this have to be planned/focused data collection process, or could the data be collected during normal trips during the workday to eventually build the entire network?
That's a great question. We get that a lot. Jay, do you mind if I answer that one?
Yeah, go ahead.
So it's a really tempting, that question goes down the road of a very, very tempting process because the equipment is relatively simple to throw in a vehicle and relatively automated. Any creative person's mind will always leap to, hey, why don't I just throw it in a car and we'll just drive around? The only caution with that is you really do need to drive with purpose. You need to ensure that you're in the lane and you're driving at consistent speed. So you really do want to, what I like to say is if you drive slow and smooth, we do the rest. So it is fully automated, but I think as Jay can speak to, and this is really why Jay and his team have been so successful, is because they spend a lot of time training their drivers to drive with purpose. So CARS is a very much a one-trick pony. Very, very tempting to look at other types of data, you know, LiDAR data or ARC data or GIS data, Google data, because all that data is there and it's free. And you're tempted to say, well, why can't I just use that for the geometry? And then, as Mike said, you apply the speed equation, you have your answer. It just doesn't work that way. And you really, the cheapest and most efficient way to do this is use this tool that was just designed for just determining the advisory speed. And with the machinery that Jay has built, and as he mentioned, he's done more advisory speeds than all our customers combined. He's got a tremendously efficient machine, but you do really have to drive with purpose. So the short answer is no, you really don't want to try to combine data collection with just your normal vehicles that are just popping around, taking video or driving to and from work.
All right, thank you, JJJ. Oh, wait, JJ, Mike.
I'm going to be
Our next topic is police training for better crash reporting from Angela Berry. Angela is a traffic safety program manager for the Engineering Operations Division for the Charlotte Department of Transportation. Ms. Berry is a registered professional engineer in North Carolina with 29 years of experience specializing in construction activities and program management.
Good morning, everybody. Let me see if I can. Are you seeing my slides, Valerie?
Yes, but it's not in full screen. There,
You got presenter mode, don't you?
yeah, presenter mode, yep.
Okay, there we go. Good morning. I'm basically going to walk you through some training that I give to our police recruit classes here at the Police Academy. I've been doing this for coming up on, I think I'm at 4 years now, and I teach every recruit class when they go through, when they're going through learning crash reports and how to fill them out. And I'm hoping to make this an elective for our ongoing police officers for their professional development hours. So first, I just want to cover how we use the data that we get from the DMV 349 here in North Carolina, some details that we go over with the police recruits, some tips I give the police recruits. I acknowledge some successes we've had from them bringing things to my attention or our attention, and then I'm happy to take questions. So I think a lot of times police officers don't realize how much the crash data from a crash report is used by the corresponding DOT agency. So for instance, we use them to justify signal requests. Our pedestrian crossing committee uses them in their evaluation. We are the only city DOT to share data with the Highway Safety Information System that is managed by the Federal Highway Administration. Obviously, we use them for crash analysis purposes. So I may have a citizen call me and say, you know, I see 5 crashes here a week. I'm able to pull up our crash database and actually quantify and qualify whether that's an accurate statement or a perceived statement. We have a transportation safety committee that meets once a month to talk about problem areas in our city. And then we also use it to map our high injury network and for Vision Zero purposes. We also occasionally have the opportunity, which isn't always good, but to address media and attorney inquiries. So I'd like to share with them details of the form that they fill out, which is called the DMV 349 here in North Carolina, that we get the at or from data and the toward data. That's important for us. That's what shows up down here in the Wilkinson Boulevard at Harley Avenue. At Wilkinson Boulevard, the intersecting road is the toward street. And at driveways in particular, giving the street address or a business name or distance from the intersection is especially useful. So without reading the narrative and looking at the crash diagram here, my staff member who geolocates every one of these crashes would have located it at Wilkinson and Newberry Street, but because of the diagram, He saw that it was at the driveway, and so was able to geolocate it appropriately to be at the driveway. This is one of my biggest pet peeves with our police officers. They have no notion of putting the north arrow up. And so I have been coaching them now for 4 years on consistently putting the north arrow up. As you can see, I have 4 different crash diagrams for the same intersection and 4 different directions on the north arrow. We also have some quirks here in North Carolina, especially here in Charlotte. This interchange, the ramps on the south side and the north side are geometrically identical. One is the inner ramp and one is the outer ramp to 485. But without any details from the police officers, we make a guess about where to code the crash. So if they don't specify the differentials in the geometry, we have to make a guess about where to geolocate that crash. And I'll give you an example. So here is one where it just says the I-485 on and off ramp, which isn't very descriptive. This just says I-485, and it just doesn't help us differentiate. Now this one, although I'm not thrilled with the north arrow pointing down, does help because he specifies which is the I-485 inner loop on ramp and the I-485 inner loop off ramp. And so this police officer helped things get geolocated properly in our crash database. I also emphasize giving us details. The officer on the left made quite an extensive narrative, talked about what business the person was pulling out of, where he stopped, very extensive details that help us make sure that we geolocate the crash even better. We oftentimes come across things like this. So in Charlotte, North Carolina, we have a pair of one-way streets in Uptown. One is College Street headed north, one is Church Street headed south. And you can see that the narrative, the crash data record says 5th and Church, where the diagram says 5th and College. And so we have to make a best guess about this. We tend to go towards the crash diagram, not the narrative. And just asking officers as I speak to them to be sure that they're putting the right terms in the right spots on their DMV 349. So this is one of 2 slides that I have that is full of words instead of pictures, but I like to reiterate the CABCO scale to officers that we actually had an officer code a horse getting hit by a car as a fatality. So just reiterating that this is to do with the people involved in the crash, not animals or other things that they may code them as. I've had bicyclists coded as pedestrians, pedestrians coded as bicyclists, a variety of issues that hopefully the sergeant would catch, but I'm not always confident that that happens. And then this helps them understand that angled crashes are different. A true angle crash most often occurs at an intersection when 2 vehicles are going straight on intersecting roads and neither vehicle is turning. This is our most commonly miscoded crash type. if they are making a turn in any way, then it becomes a subcategory of an angle crash, such as a left turn different roadway or left turn same roadway. Now for some tips that I like to give officers. They often aren't aware of this, but in Charlotte, skip markings are 10-foot long with a 30-foot separation. So if you count the skip lines, you can actually estimate distances from intersections or businesses. And then I like to talk about speed. At 20 miles per hour, 1 out of 10 pedestrians hit by a vehicle is likely to die. If you simply double that, the number of fatalities goes up exponentially, and most likely 9 out of 10 of your pedestrians will be killed. The other important factor here is that pedestrians and bicyclists account for less than 5% of our crashes here in Charlotte, but they account for nearly 40% of our fatalities. So this crash diagram was done very well by a police officer. I might have coded it to Woodlawn and Park Road, but instead he actually gave business addresses and driveways, and we were able to code it appropriately to be further down the street from the intersection so that it didn't count towards the intersection crashes. We have some weird things here in Charlotte where streets intersect streets twice. So for instance, Ballantyne Corporate Place intersects Ballantyne Commons Parkway in 2 locations. It's a half U basically, or a U-shaped street without street addresses or landmarks. Again, we have to take our best guess at where to geolocate this crash. I also asked the officers to read the website called crashnotaccident.com for why they should change their terminology from accident to crash. It's a very powerful, I think, reading. Asks you to take a pledge. I also share the Vision Zero website with them here in Charlotte. And then I usually share, we have an internal city network mapping system with many layers that they don't know is available to them. I don't know why the police department doesn't know about this because the rest of us do. But it's called Charlotte Explorer. And so I share that with them as well. This is one of our biggest successes with the police department. We had a police officer come to our transportation safety committee and tell us that he was responding to a crash here every day at the driveway into a Walmart. And when we pulled the crash history, sure enough, he was responding to at least 1 crash every day, if not more than 1 crash every day. And they were left turn, same roadway crashes. And we actually signalized this intersection based on that officer bringing it to our attention, where we might not have noticed it otherwise. We also installed LED streetlights along South Tryon based on the police reporting to us that they were seeing a higher incidence of dark nighttime crashes. And so we put streetlights on, sorry, tongue's not working with the brain this morning. We put streetlights on approximately 3 miles of roadway at a cost of about $25,000. And that actually just recently wrapped up. And so with that, I really just wanted to share with you that you have an opportunity as safety professionals to educate your police officers on how you use the data that they provide to you and make sure that they're aware that you use that data on a daily basis for making decisions about how to spend capital dollars. And with that, I will wrap up and take any questions.
Okay, I actually have some questions. I have one
Oh, great.
myself. Someone has one up here, but my mouse stopped working. Well, I think it's actually the system is slow. My system, that is.
Okay.
Can't. Well, I'll ask my question. Hopefully
Okay.
my system will. Oh, there we go. Question for Charlotte. Vision 0, do you apply a value of statistical life VSL for benefit cost analysis and project selection? And if so, what VSL value do you use? Seems like the latest info on VSL was published by the feds in 2016.
I'm not sure what VSL is. We actually use crash modification factors from the CMF clearinghouse, and we do a benefit cost analysis. We are actually going with a new software vendor to house our crash data that will have a the ability for us to use CMFs on a basically the click of a mouse, apply them to various scenarios. So I'm really excited about that opportunity.
Is there a separate entity or is it linked to EEAS? Uh-oh, did you hear me?
I did hear you.
My
I'm not sure
system's
that
not
I know what.
responding really well.
I'm not sure that I know
Okay.
what EEAS is. If the person could type in,
It's the
make it.
TEAS program, Angela, with DOT.
I'm sorry. Yes, we do report all our data is reported to the state as well as to ourselves. So it is linked to TEAS. We just do it on a daily basis, whereas TEAS tends to lag. I'm trying to. Here we go.
How does the police department react to your training? Do you think it is lecturing or is it positive experience? I have a similar question. Did the police come to you or did you go to them?
I actually went to them, and they have found it to be very beneficial, I think, especially my officers that investigate my fatal and serious injury crashes. They all inevitably put the north arrow up now, which is a marvelous thing. Even though it's a horrible situation to have to investigate a fatal or serious injury crash. But I have found that the police officers are very interested, especially when they find out that I know how signals operate. And so I get a lot of operational questions about, you know, I pulled up to a signal on my bicycle and the loop didn't detect me. I explain how a loop works, that it's an electromagnetic field that is broken by the metal of your car. So I've found very positive feedback from the police department.
I work in a very similar area, and what we've done with our police is that, well, at least before COVID, we would meet every other month and bring things together and comments, and it was a great forum to be able to do it. Now we have to do it more virtually, but we give them presentations on what types of projects we have out there, what changes are coming up. They bring to us problems, sort of like you said, that one officer was like, this has a lot of crashes. We get very similar types of things back from just being able to have a stakeholder police traffic engineering, traffic operations meeting. I did have another question, is that do your officers use GPS when they're locating intersections? Because that's something our officers have done. So even if they get it wrong, they generally, as long as they're standing where the crash is and write down the GPS coordinates, they're at least, we've got the right place for them.
Yeah, unfortunately, our officers have not done that, especially because a lot of times they'll do the paperwork sort of after the fact in a parking lot nearby or back at the station house. And so we have not found GPS to be very reliable, which is why I have one staff member who does nothing but geolocate crashes to make sure they're located in the right location.
And then what methods have you found to be most effective to alter documentation behaviors of officers? Has any particular recommendations been more effective than others? Do you have training class for officers as well?
So I'm hoping to do an elective this spring for regular officers who've already graduated from the academy and have been out. You know, really just the communication so that they understand that filling out a crash report, even if it's a property damage only crash report, has data in it that is used by Charlotte DOT to make decisions about infrastructure and how we spend. In some cases, you know, I'll use our traffic control devices upgrade program. You know, in some cases, he's making decisions about where to spend millions of dollars on new signals across our city based on crash history. So it can be very important.
I think that's the end of the questions, unless I missed one. Just, whoops, this is my touch screen.
Somebody asked about pushback from the officers.
I think that's it.
Okay. Did you want me to answer the one about pushback?
Sure.
So actually the officer who teaches about the DMV 349 has been converted to using the word crash, not accident. And anytime a recruit in his class uses the word accident, they actually have to do a burpee. So they're pretty good about converting pretty quickly to not having to do burpees. I don't know if you know what a burpee is. I didn't know what one was either until he made the officer do one. And it's a pretty intense physical experience to have to drop down on the ground, do a push-up, and then jump back up and do a jumping jack. Is pretty intensive. So they get cured of the crash not accident pretty quickly.
All right. That brings us to the end of this session. Thank you all for coming.